Yeah, hello viewers. Yeah, welcome to my YouTube channel, Mathematics Media. So, in today's video, we'll be looking into this beautiful problem. So, this is under the vector calculus vector field to be precise. Okay, so we'll be looking into call of a vector field. So, there's a problem from the call of a vector field, and then the general topic is vector calculus, and then it's vector fields, and then we do this thing also in multivariable calculus. Okay, so the question before us is if f of x, y, z equal to x to the second power of y, z high plus x, y, z to the second power j plus y to the second power zk. So we have to determine the call of f at the point 2, comma 1, comma 1. Okay, so that is the problem we want to solve for today. Okay, guys, so before we dive into the solution, so if you are new to this channel, don't forget to subscribe, don't forget to like, don't forget to comment, and also share. And click the notification button so that anytime we upload video, you'll be the first to watch. Alright, guys, now to not waste much of our time, so let's dive into the solution. Okay, now that's good. Now this is what I'm gonna write. I'm gonna write down the equation, and here is the question. Okay, so we have f of x comma y comma z, so which is equal to x to the second power y z high, okay, plus x y z to the second power j, then plus y square z k. All right, now the first thing, if you want to find the call, okay, the call of a vector field, so we have the call of f, so which is now equal to, is in a matrix form. Okay, so we have I, we have j, k, we have j, we have k, then we have d dx, okay, we have d dy, okay, we have d dz. All right, so then I can call this p q r. Okay, now in this case PQR, in this case, what is my P? My P is equal to this guy with I, which is x to the second power y multiplied by z, and my Q is this guy with J, which is x y multiplied by z to the second power, and my R is equal to y to the second power multiplied by z. All right, now the next thing we are going to do now is to find the determinant of this matrix, and I'm sure you guys know how to find the determinant of a 3 by 3 matrix. Now you take this, so you use I, so we have the call of f is equal to, if you take I, so this will be d dy of r, that will be dr over dy, all right, then multiply by dq over the z, then high, okay, then followed by g, so minus, okay, we have the r over the x minus the p over the z, so we have j, and the last one we have the q over the x minus the p over the y multiplied by k. All right, so you take it one after the other. You have plus, you have minus, you have plus. So for the first one we have plus, which is I. For the second one we have minus, which is j, and for the third one we have plus, which is k. All right, then next thing we are going to do for us to be able to complete the question is to find the r, the y, the q, the z, the r dx, the p dz, the q dx, and the p dy. Okay, so the r over the y will be equal to what? Now look at this. We have r is equal to y to the second power multiplied by z. So the r, the y will be equal to what? That is, you have to differentiate this with respect to y. So you make your z to be constant and you differentiate with respect to y. So if you do that, you're going to have 2yz. Alright, so that is our dr, the y. Next thing is to find the q, the z. Now, the q, the z. Now look at your q, you have x, y, z squared. So you'll be differentiating z to the second power, and then you take x and y as a constant. So if we do that, we're going to have 2xy z. So that is the q, the z. The next one is to find your dr, dx. So dr, dx will be equal to, we're going to differentiate this with respect to x. And then if you check this, we don't have x here. So if we differentiate a constant, that is 0, because we'll be taking y to the second power and z as a constant. I hope you get me now. Since we have to differentiate with respect to x, so definitely this will be 0. That is dr dx. The next is the p, the z. The p, the z. P is x to the second power y multiplied by z. That is, you have to differentiate this with respect to z. Then if you do that, we have x to the second power multiplied by y. And the next one is the q dx. Okay, so the q dx will be equal to, you have q equals x y z to the second power. Okay, then you differentiate it with respect to x, then we're going to have y multiplied by z to the second power. And the last one, which is the p dy. So where p is x to the second power y multiplied by z, so that we have the p dy, which is equal to, here we want to differentiate with respect to y, then take x to the second power and z as a constant. And then if you differentiate y, you got 1. So we have x to the second power multiplied by z. Good, that's cool. Since we've gotten all the derivative we need, so we can now successfully find our call of f. So call of f will be equal to dr dy, which is 2yz, minus dq dz, which is 2xyz. Okay, then multiply by I, then minus dr dx, which is 0, then minus the p dz, which is x to the second power multiplied by y. Then you put j. And the last, the q dx, which is yz to the second power, minus the p dy, which is x to the second power multiplied by z. So sorry, we have k. Yeah, that's cool. That's cool. So what are we going to do next? Yeah, so we can simplify this, that we have the call of f finally is equal to 2yz minus 2xyz, then I, then minus 0 minus x to the second power, so that's going to give us negative s to the second power y. Then negative times negative will give us positive, so we have positive x to the second power, then j, then plus y z to the second power minus x to the second power z. Okay, but remember from the question we're given 3 points. All right, 3 points. So which let me check. The 3 points given to us is 2 1 1 2 1 1. So this means that the call of f at the point 2 comma 1 comma 1 will be equal to what? It means your x is 2, your y is 1, and your z is 1. Okay, so we have 2 into bracket y, which is 1, z, which is also 1, then minus 2x, x is 2, y is 1, z is 1. Hi. Then plus x to the second power, x is 2, 2 to the second power, y is 1, then we have j. Then plus, y is also 1, z is 1, so we have 1 to the second power, minus x is 2, 2 to the second power, and z is 1, so we have k. So we have the call of f at 2 comma 1 comma 1 equals 2 times 1 will give us 2, then negative 2 times 2 will give us negative 4, then we have high, then plus 2 to the second power will give us 4, so we have 4j, then plus 1 times 1 will give us 1, then 2 to the second power will give us 4, so we have 1 minus 4, then we have k. So finally we have the call of f at 2 comma 1 comma 1 equals 2 minus 4 will give us negative 2, so we have negative I, then plus 4j, then minus 3k. All right, so that is beautiful. So that's the answer to the problem. And then if you like, you can write this in form of vector. All right, so if you write this in form of vector, this is negative 2i, so you have negative 2. This is 4j, you have 4, and for the last one, which is k, we have negative 3 in vector form. All right, so that is the answer to the problem. So if you like this kind of video, please don't forget to subscribe to my channel, like my videos, comment, and also share. Thanks for watching. See you next time. Goodbye.